In this example, we're going to use several formulas given from the text to determine the exact and approximate doubling times. So we are comparing these two doubling times, and we're given this information that inflation is causing prices to rise at a rate of 7% per year. For an item that costs $300 today, what will be the price in 4 years? So the first thing we're asked to do is calculate the doubling times. And you'll notice I've already included those two formulas here to the side. There's an approximate doubling time formula, and I know symbolically it's approximate because of that symbol. Notice it's the approximation sign, not the equal sign. And then there's also the exact formula. Okay, so I'm going to show this in my calculator. For the approximate formula, all I have to do here is do 70 divided by the percent as the value it's given here. So I'm going to type in 7. I do not need to change that to a decimal, in other words. And that's how I get 10 years. So that's that rule of 70. You may have seen even in other classes. And we expect that it takes about 10 years for this to double. But when we use the exact doubling time formula, notice that it has that word log. And there is a part in the text that goes back and explains that function, the log function, short for logarithmic. But where that's located on your calculator is here, log. So you just have to be careful sometimes with parentheses. It depends on maybe what type of calculator you're using as to how this may appear. So please reach out if you're trying to use a different calculator and you're uncertain about using the log function on your calculator. But when I look at this and I see log with a base of 10, the calculator uses log with a base of 10 with this key. So notice it doesn't put the base 10 there, but it's understood to be there. So you're okay as long as if in print it says base 10, or if there's no base even written, that's the same as this key on your calculator. So we're going to do log of 2, and then we'll divide that by log of 1 plus the percent written as a decimal. So instead of 7, we'll write 0.07. And this is how we get the exact doubling time, and it does ask you to round to 2 decimal places. So for comparison, you can see that the approximate doubling time is less than the exact doubling time. And then if an item costs $300 today, what will be the price in 4 years? Here's this formula. Again, I've just copied this from the text. So to get this new value, we start with the initial value, which is $300. We're going to multiply that by 2 raised, so this is in the exponent here, the time in years, which will be 4, divided by the time it takes to double. And we just determined that in this last line here. So that was 10.24. And that's how we get this price rounded to the nearest cent, of course. Again, if by chance and you're in your calculator and it doesn't look the same as this, it may be you need to update the operating system. Please let me know. Or if you would like to see this in other, like maybe online calculators like Desmos, please let me know and I can make a video for that too.